Alright, so there's two problems I want you to factor for me. So the first problem, 6x squared minus 24x minus 5x plus 20. And the second problem, oh, I'll pull that down in just a sec. Go with 16x squared minus 24x plus 4x minus 6. So two problems. Try factoring those two problems. Let me put that screen down. So everyone saw that these had four terms, and we were going to factor by grouping like we did last time. And there were a couple of little tricks or things you really had to be looking for in each of these problems. So for the first one, I'm going to split my groups in two. And what's going to be the greatest common factor in my first group? 6x. So I can take 6 from both 6 and negative 24, and they have x's in common, so we're going to factor out a 6x. And again, you don't necessarily have to write the division, but I saw a lot of people did to kind of see what's left over. And that's going to give me x minus 4. So our ultimate goal here is to match that x minus 4. Because if we get another x minus 4, we know we can factor it out. So I have x minus 4, but my next group starts with negative 5x plus 20. So what am I going to have to use for my greatest common factor there? Negative 5. We're going to have to use a negative greatest common factor. It starts with a negative, and we need to switch the signs from negative positive to positive negative. They're backwards. That's when you use that negative GCF. So we're going to factor out a negative 5, divide each of these by negative 5, and be really careful with your signs here because it does switch them both. So you get your x minus 4. Once you get your x minus 4, you should be good to factor that out. Even though you see it what looks like twice, that comes only once in your answer. That's kind of a common mistake, is that people are like x minus 4, x minus 4. Other stuff might get forgotten. Maybe we got too many factors, but whatever that common binomial is comes out once, just once. And then what's going to be in my other factor? 6x minus 5, those GCFs. Now, if you had your answer as 6x minus 5, x minus 4, it's the exact same thing. That does not matter. That order does not matter. Now, for the second one, I caught some of you not factoring completely. You went right to grouping because you saw the four terms, which is fine because you can always correct at the end, but you have to remember to look for it. That's why I suggest you just start every problem, and you'll see today, sometimes it saves us a lot of work to take that greatest common factor out first. So first thing to always look for is that greatest common factor. So 16x squared minus 24x plus 4x minus 6. Greatest common factor to all of them? 2. I recommend starting here. Again, you can handle it at the end if you recognize it. So that's going to give me 8x squared minus 12x plus 2x minus 3. And now just kind of ignoring the 2, putting it on the back burner. It's part of our answer, but it does not affect our grouping. I'm going to split the other four terms in half and go back to the grouping. So if I do that, what's my greatest common factor for 8x squared minus 12x? 4x. Divide each of these by 4x. And that's going to give me 2x minus 3. Again, we've got this 2. Distance it so it doesn't get in the way of our grouping. What's the greatest common factor in my second group? 1. Remember, I said 1's always a common factor to a polynomial. In this case, it's the greatest common factor. And since it's in the middle of a problem, we really do care that 1 is the greatest common factor. So I'm actually going to put 1 times 2x minus 3. Just to really make it look like our other problems where we have something in front of that second group. Now, do you have to put the 1 there? Not necessarily, but you need to know that there's a 1 there so that you have something to go to in your next step. So 2's hanging out front. 2x minus 3 is my common binomial. and then I have 4x plus 1. That is factored completely. Now, on some people, several people's papers I saw, actually, they had the 2x minus 3 first. Got down to the answer 2x minus 3, 8x plus 2. And even if you try checking it, you're going to say, okay, it checks out. It gives you back the original problem. But where you're going to lose, usually just a point on this problem, would be that's not factored completely. Because if I look at this second factor, there's something in common to both of those terms. So you can certainly handle this at the end. You would look at each factor and make sure there's no GCF in each factor. So what's the greatest common factor for 8x plus 2? 2. So you could still take a 2 out, but you're only taking it out of this one factor. And you're going to see if you take that 2 out at the end, you still get the same answer. But you've got to remember to look for it. But you can still get there without starting the problem. So any questions going back to our grouping? It's really important to be able to group today. If you can group today and you can find pairs of numbers like we did on the end of Friday, you've got factoring our trinomials down. Questions? Yeah. Well, we're going to do like 6 factoring examples that all have this in it now. All right, so let's go back to our notes then. So if you want to take out your guided notes. So the first thing I want to talk about is actually a method. It's a valid method. I don't really recommend it, but I have some people that are very good at this. It's called factoring by guessing and checking. But as a reminder, before that, where do you start every factoring problem ever? GCF. Always start with the greatest common factor. Now, this guess and check method, whenever you're factoring a trinomial, first thing to look for, greatest common factor. Generally speaking, the way it ends up at the end looks like a FOIL problem. So a binomial times a binomial. So one way you could, if you kind of all else fails on a test, factor problem is guess what you think it would look like. So it's going to be something times something. And then you just kind of put numbers in and hope when you check it, when you FOIL it back out, you get to see this. Now there's a little bit of a system to guessing and checking. So when you guess and check, the first 2 terms in each binomial need to multiply to 3x squared. So can anyone think of a way to multiply to 3x squared? Something times something gives me 3x squared. 1x times 3x, yeah. Generally you put the one that has the higher number first like that. So 3x times x gives me 3x squared. So if I were to go and check this, if I were to go and FOIL this, 3x times x gives me my 3x squared. Now, if you're getting lost here, that's okay. We're going to have a do this method that's much better than guessing and checking. I just want to put this out here that this is a possibility. So the other thing when you're doing your guess and check, if this is kind of what you're resorting to, the last 2 need to multiply to -2. And then you're just going to play with signs until the whole problem works out that your middle term comes out. So, well, that's not bad, right? So 2, there's only 2 ways I can multiply to 2, because order does matter for these problems. 1 times 2, or 2 times 1. So I need to get a -2, which means one of those numbers has to be negative, right? Negative times positive gives me negative. Okay, so, well, there's 2 different possibilities we could possibly guess. But these are 2 more possibilities. So say you're a really bad guesser. The most that you could guess wrong on this problem would be 3 times, and then 4th try you're going to get the right answer. You could also do it kind of looking ahead at what you think might work. But again, still not too bad. Probably won't take too much time. So has anyone got a favorite pair? One of these 4 that you think when I put them in here and we FOIL this back out, we get the original problem? It's a guess. We're guessing. We want to try pair 1, 2, 3, or 4. 2. Pair 2. Okay? So here's our first guess. So this is our guess. Is that if I use this pair. When I FOIL this back out, I get my original problem. It's a guess. So I'm going to now do the second part of guess and check, which is check it. And the check just involves FOILing, seeing if I get back my problem. So I'm going to get 3x squared plus 6x minus 1x, minus 2. And then when I combine my middle two terms, I have 3x squared plus 5x minus 2. Did it check? No. So this can't possibly be it. That guess didn't work, because this should be minus 5, not a plus 5. So with guess and check, the next thing you do is you guess again. So we know the only possibility for my 3x squared is 3x and x. But now, okay, that didn't work. Down to 3 more possibilities. First one. So let's put in our next guess. -2 plus 1. Now for our check. To check it, you FOIL it. I'm going to get 3x squared plus 3x minus 2x minus 2, which is 3x squared plus x minus 2. Is that my original problem? All right, we got to take that one off. So you see, this is not necessarily an efficient method, but if you can FOIL in your head, which is a real possibility, if you can FOIL in your head, it's not a bad choice. So what we're looking at, anyone got the pair down to the last two? Brittany. 1 and -2. So 3x squared, this would be our next guess. 3x, plus 1. Oops, that should just say x, not 3x there. X minus 2. Let's try getting that. And when you check it, you get 3x squared minus 6x plus x minus 2, which is 3x squared minus 5x minus 2. So after all that, we know our answer. The answer is the guess. So that was a lot of work. It was a lot of maybe, try it, maybe, try it. But again, reasonable. But look at this next one. So 12x squared minus x minus 20. Well, we know that the first two terms have to multiply to 12x squared. But the problem with 12x squared is that it could be 12x times 1x, or it could be 6x times 2x, or it could be 3x times... All right, so now we've upped it to 3 different possibilities just to start each set of parentheses. And then the 20 at the end, well, 1 times 20, 2 times 10, 4 times 5. But because it's negative, we know we need 1 negative. But like with the previous example, we also have to account for the opposite signs on each of those pairs. So there are a lot more things you're going to be guessing here, which is why I don't really recommend it. Again, sometimes I have students who are very good at guess and check. I absolutely accept it. Not the most efficient method. In case you're wondering, the answer to this one, we're not going to guess and check it, is 4x plus 5 times 3x minus 4. If you FOIL that out, you get back your problem. But what we're going to do now is we're going to learn a surefire method that every time will get you to your answer. No guessing. So if you turn now, we did the table, did that. All right, one of the prerequisites, the kind of last skill we need, prerequisite skill to our factoring is you need to identify what are called A, B, and C. So where are my directions on here? Here we go. So A, B, and C are the coefficients of our factoring quadratics. So whenever you look at one of these problems, this is the form. AX squared plus BX plus c. So where this is in your notes, I see some of you flipping through. So we did the little table. Yours are just spaced a little bit differently, so you can see them. There's the directions for factoring trinomials by the AC method. Then it says identify A, B, and C. Maybe? People find it? Look, you're too far. Yes. Not sure. All right, so A is the number in front of x squared, and this is a skill that you'll need in more units than one. A is in front of x squared, B is in front of x, and C is the constant at the end. So you don't include the x's when you identify A, B, and C. It's just the numbers in front. So if I look at this first example, A here is just the number 2. B here is the number -4. And C is the constant on the end, 5. Notice in A, B, and C, there are no variables. It's just the coefficients. So in my second example, what do you think A is? 1, the number in front of x squared. And if there's nothing written there, it's a 1. So very similarly, what's the number in front of x? -1. And then C, my constant at the end? -7. So make sure when you're identifying A, B, and C that you don't put any variables with them. It's just the coefficients. In front of x squared, in front of x, the constant at the end. So now let's put all of this together and factor trinomials. So this is what we're trying to factor here. We're trying to factor 2x squared plus 11x plus 5. Now for the first two examples, I call them the training wheels. Really worked out each step, and then we'll do some that have just the problem written out. So the first thing you want to look for in each of these problems is a greatest common factor. So do I have a greatest common factor other than 1 for this trinomial? No. Okay, so we don't have one of those here, not in this problem. Next thing I need are A, B, and C. So what's A in this problem? 2. The number in front of x squared is A. What's B? 11. The number in front of x. And C is 5. And whenever we factor trinomials, we're going to use what's called the AC method. And that's because we're going to start by using A and C. So it's called the AC method because we're going to start by multiplying A times C. So A was 2, C is 5, so I multiply them together, I get 10. Now, I usually bring down B at this point. I always say I don't like to leave out B. So A times C gives me 10. B we identified above is 11. And the reason I want these two numbers, I need AC and then I want B separately, is I need to find my pair. And this goes back to what we did on Friday in that table. What I'm looking for is a pair that multiplies to whatever AC was, which is 10. So I need my pair that multiplies to 10 and at the same time adds to whatever B was. Adds to 11. And if you did this in school, sometimes you use the X, where you put the 1 at the top and the 1 at the bottom. That's cool too. I always do lines, but however you're used to seeing it. Devin. 10 and 1, perfect. So this again, it goes back to what we did in that table. Pair multiplies to 10, adds to 11, which is 10 and 1. Now, if you wrote 1 first and 10 second, that's fine. That order doesn't matter. The rest of your problem will look a little different. You'll get down to the same answer. But any questions on the pair 10 and 1, fulfilling, multiply to 10, add to 11? Now the next step is the one that people forget. This is the one people find the pair and then they forget what to do with it. I want to factor this by grouping. How many terms do I need to factor by grouping? 4. How many do I have in my original problem? 3. These two numbers are going to replace one of them in my original problem, and that's going to give me 4 terms, because I'm going to replace, I had 3 terms, I'm going to replace one of them, and now I'm going to have 4 altogether. Which one of those terms can get replaced with a 10 and a 1 without changing its value? B. It's always the middle. So I can't replace 2x squared with 10 and 1. They're never going to make 2. But where do I see a combination of 10 and 1? Well, right here, 11x. We know 10 and 1 equal 11. That's why we found that pair. You're always switching out the middle term. You're switching the middle term with this pair. So when you switch the middle term, so we're not doing anything to the first term. We still have 2x squared. When you switch the middle term, make sure it's not just 10 and 1. It's 10x and 1x. Because if you put 10 and 1, you've changed it. It's 11. I don't want 11. I want 11x. So they have to have the x on them. And then the last term, we're not doing anything with that either. So we're doing all this work to find this pair simply to switch out the middle term. Because now I have 4 terms. I can go back to what we did on Friday. I can factor it by grouping. So factoring trinomials just has an added step. Make it 4 terms, go back to your grouping. So if I split this in half now, so I've got my 4 terms, I'm going to factor by grouping. What's the GCF in my first group? 2, and I heard someone say the other part of it. X. Both of them have an x. A lot of times, most of the time, that first group has an x in it. So I'm going to divide these each by 2x. And that's going to give me x plus 5. What's the greatest common factor in my second group? 1. Remember, that 1 is always present. So I'm going to use a 1 for the GCF here, which gives me x plus 5. And then there's one more step to factoring. What's my answer? X plus 5, 2x plus 1. Now your final answer, if you had a GCF, make sure it comes out front, and then it's our common binomial, and our leftovers factor. Now how can I check this? FOIL it. You could check every factoring problem. Check this by foiling. So this is our answer. To check it, I'm going to FOIL it, which gives me 2x squared plus x plus 10x plus 5. And when I combine the middle 2 terms together, sure enough, I get back my original problem. So people always ask, do I have to check my answers? No, but if you have time, why not? Questions? This is a very important type of factoring. We'll be doing a lot of this in Unit 1, a lot of this in Unit 2. You typically see a standalone one of these on your final exam as well. All right, let's do another one. Another 5, I think. All right, so next problem, I'm going to factor completely 10y squared plus 26y minus 12. First thing I want to look for is GCF, greatest common factor. Do I have a greatest common factor in this problem? 2. So we're going to take that out first. So 2 out front. Divide each of these by 2. So now I'm working with 5y squared plus 13y minus 6. So what's A for my problem going to be? 5. So what we're trying to factor now is what's in my brackets. So we're not looking at our original problem anymore because we took a 2 out of everything. So we're going to get A, B, and C, and this is why that GCF at the start actually saves you a lot of work. It can make your numbers much more manageable here. So A is 5, B is 13, C is negative 6. So now I want to multiply A times C. That's why we call this the AC method. A times C. This means negative 30. And B we said was 13. So the pair I'm looking for needs to multiply to AC. So it needs to multiply to negative 30 and add to 13. Now this one might not be quite as obvious as the first one. So remember, if you're getting stuck on finding your pair, you always focus on the number that you're trying to multiply to. And look at every way I can multiply to 30. So 1 and 30, 2 and 15, 3 and 10, 5 and 6. And then play with your pairs to see which one can multiply to a negative 30 while at the same time adding to a positive 13. What are you at, Napoleon? 2 and 15. And what are your signs going to be? Negative 2 and positive 15. So the other tempting pair with this is the 3 and 10, but you could never get to a negative 30 while keeping a positive 13. Now if you put 15, then negative 2, you will get the same answer in the end. Your groups will just look different. So if you're working ahead and you went for 15 minus 2, keep going. So why do I go through all that work? Why do I go through all the work to find that pair? Devin. To replace the middle term. We're always trying to replace the middle term with our pair. 13 and 13. So I'm going to, again, the 2's just kind of hanging out front like we did in our other problems. It's not affecting my grouping at all. So I keep the 5y squared, but I switch out the 13y for negative 2y plus 15y. And I keep the negative 6. Any questions so far on kind of where this line came from? So I'm going back to, after my GCF, the 2's out front. 5y squared, it's just a copy down. We split the middle term. So the middle term was 13y, but we have another pair that makes 13, negative 2 and 15. Anna. If you're having trouble, you can, but this will work. This will work. But yeah, go ahead and switch it and then work it out and see if you get the same final answer. So now I'm going to go to grouping because I have 4 terms. That's what we're trying to do. We try to make 3 and a 4 so we can go back to our grouping, something that we know. So what's my common factor for 5y squared minus 2y? What do they have in common? Y. They both have a y. They do not have a numerical greatest common factor, but they both have a y. So if I factor that out, I'm going to have 5y minus 2. And then what's the greatest common factor for 15y minus 6? 3. I'm not changing the sign, so I'm going to use a positive 3. If I factor it out, it's going to be 5y minus 2. So then my final answer from my grouping is 5y minus 2, y plus 3, and don't forget that 2 needs to be out front. So did you have 2y plus 3, 5y minus 2?
I end up getting 5y, and then in parentheses 1y. Well, it's actually y plus 3, and then it's negative 2, and then y minus 3. So what did I do?
I'll have to look at that. I'll look at it at the.
Okay.
I didn't switch them. If you switched on, your GCF in your first group would be 5y, and the GCF in your second group would be negative 2.
Yeah,
Yep.
I did that.
So then look at your step of factoring that out, is I'm guessing where there might be a problem. So that's going to be our final answer. This one, people have a harder time with the check on because there's 3 factors here. There's 2 different ways you could check this. Whenever you're multiplying 3 things together, you just have to multiply 2 of them, get an answer, multiply that by the third. So one way I think that maybe makes it easier for people or is easier to check, so again, this is our check, which is our FOIL, is to start by foiling the 2 binomials together and then just distributing a 2. I think less errors get made that way. So you'd have 5y squared minus, sorry, I'm not going in the right order, 5y squared plus 15y minus 2y minus 6. You can either distribute, combine your like terms. So 2 times 5y squared plus 13y minus 6, and then distribute the 2. And you're going to get back your original 10y squared plus 26y minus 12. Yeah.
Okay, I only did it I got the right answer. 5 plus 3 and 5y minus 2. But the 2, I didn't
You just got to carry it down.
carry it.
Yep, the GCF2 just comes down. And even if, I'm okay if you put it in the first step and in your answer, but you got to make sure you include it. The other way that you could check is you could start by distributing the 2, but you don't distribute the 2 into both sets of parentheses, which is where people make a mistake. If you want to start by distributing the 2, you would only distribute it into the first set of parentheses. When it hits the closed parenthesis, it hits a wall and it's done. So you would end up with this factor being 10y minus 4 times y plus 3, and then you'd FOIL second. But where people make the mistake here is that they just distribute the 2 into both sets of parentheses and then try FOILing it, and it doesn't check. So if you're going to distribute first on your check, it only goes into one set of parentheses. Then you FOIL it with the other. So 2 options to check there. Questions? If you can FOIL it out, you'll get the same thing. So when you go home and you're doing these all by yourself, you're not going to have this, do this, then this, then this, then this. So when you go home and you're staring at it, it's just going to be a blank page. So our next problems, that's what it's going to look like. You get home, that's what you're going to see. So I want to factor 6x cubed plus 24x squared minus 30x. Well, the first thing that's already different about this is it's got x to the third power. We're not used to seeing that. So 6x cubed plus 24x, sorry, 6x cubed plus 24x squared minus 30x. First thing you always look for? GCF. What's my greatest common factor here? 6x. We're going to want to take that extra x out because we're not used to seeing an x cubed. So let's start with our GCF is 6x. So we're going to go through and just take 6x from everything. And that's going to leave me with x squared plus 4x minus 5. So what we're trying to factor here is we're going to factor the trinomial now, which is what we're learning today. Now we can factor trinomials by the AC method. So first thing we need here is A, B, and C. So again, we're looking at what's in the parentheses. What's my A? 1. There's a 1 in front of that x squared. B? Positive 4. And C? Negative 5. Again, you shouldn't have any x's in those. So we're going to work with the AC method, which means take A and multiply it by C. So 1 times negative 5 gives me negative 5. And let's not leave out B, which is positive 4. So I need the pair that multiplies to negative 5 and adds to positive 4. 5 and negative 1. And again, if you put negative 1 and 5, you're going to get the same answer. Your groups will just be different. So 5 times negative 1 is negative 5. 5 plus negative 1, positive 4. There is only one pair that ever meets that condition. Why do I find that pair? What do I do with that pair? Switch it out with the middle terms. Notice that's 4 and that's 4. We're always going to split the middle term. So this 6x, again, I'm going to just kind of distance it as far as I can. It's still there. It's not affecting my grouping. I copy down the x squared. So the x squared, let's skip through, just comes straight down. The middle term gets replaced with my pair. Don't forget your variable when you replace. And then my last term just comes straight down. Now that I've got 4 terms there, what type of factoring do I do? Grouping. So I'm going to split these 4 in half. Again, the 6x is just hanging out. We can just bring it back at the end if you want. What's the GCF for x squared plus 5x? What does both have in common? X. So take out just the x. That gives me x plus 5. What do I have to factor out of that second group so I get my x plus 5 back? -1. So we're trying to switch those signs around to get x plus 5. Now for my answer, I take that common factor once, x plus 5. Build the other factor, x minus 1. And what else needs to be in my answer? Yeah, GCF. Questions? Again, it's practice. We do the same thing every time. Just practice on remembering what comes where. Alright, so let's look at x squared minus 9x plus 14. So, GCF? No. So, let's go for A, B, and C. Since it's a trinomial, the only time you use this method is when there's 3 terms. So, A is 1, B is -9, and C is 14. We can do the AC method. We multiply A times C, which is 1 times 14 is 14. B is -9. So I'm looking for a pair of numbers that multiplies to 14 and adds to -9. -7, -2. And where's that pair going? In the middle. The pair is always going in the middle. So I'm going to have x squared minus 7x minus 2x plus 14. Split this in half. What's the GCF in my first group? X. Factor that out. I'm going to be left with x minus 7. GCF in my second group? -2. So I need to take out a 2, but in order to switch the signs around, we're going to use a negative GCF, which gives me x minus 7. Got your match. X minus 7, x minus 2. Now, in our last, we've got a couple minutes left. I want to point out a shortcut. But this shortcut only applies to particular problems. If we could do this to every problem, it wouldn't be a shortcut. It would be the method we used. Look at your answer here. X minus 7, x minus 2. Where did we see -7 and -2 earlier in this problem? Devin. Yeah, look, right here. -7, -2. Those came right down to our answer. Look right up here. +5, -1. Where did those come from? Right up here. There's only one time this works. If you look at our other problems, it doesn't work. No, because I had a GCF in this problem. The only time that you can skip the grouping is if A equals 1. If A equals 1, we have a shortcut. That's the only time this works. If A is even -1, this doesn't work. So I just want to show you how that works on one problem, and then that's all we're going to have time for. We're not going to get to the last problem. So if I look at E, there's no GCF, but there's that golden fact that A equals 1. B equals -8, and C equals 16. This lets me use a shortcut. We're still going to find our pair of numbers the same way. A times C is 16. B is -8. So we're still doing this the same. I want two numbers that multiply to 16 and add to -8. -4, -4. Now what the shortcut says is we can skip the grouping and go right to our factors. When you're doing the shortcut, both of your factors always start with x. That's part of the shortcut, because x times x gives me back the x squared. But what the shortcut says is just take that pair of numbers, put them right into your factors. You don't have to go through the grouping. Now, if you're afraid you're going to abuse this power or it doesn't quite make sense, go through the grouping. The grouping works every time. This will save you a step. But this only works if A equals 1. If you got a 2 there, or 3 there, anything else, you've got to go through all the grouping. So your homework for tonight, I didn't write it on the board, but I will put it up there. Homework is the 6263 problems. I will pick from there for your drill on Wednesday. Some of those you can apply that shortcut to if you want to try it out. Just check your answers. The rest you've got to go through the full AC method or guess and check, whatever you want. Have a wonderful afternoon. Stay dry, stay warm. I'll see you on Wednesday. Let me know what you have questions with.